This video is going to cover the topic of solving inequalities. Be sure the date and topic are at the top of your page. The essential question for this video will be, how do we solve inequalities? And as we already know, inequalities are the equations that use symbols such as less than, greater than, less than or equal to, or greater than or equal to. So for example, if x is less than 5, that means the value of x could be anything so long as it is smaller than the value of 5. And we know that we set that up to show on a number line all of the ways that we could solve this inequality by saying any number less than 5. Sometimes inequalities look like this, where we have 4x minus 8 is greater than 12. And we don't know what the missing value is, but we know that if we multiply it by 4 and then we subtract 8, we would end up with a total that is larger than 12. So the question becomes, what are possible values for x? Well, we can just solve the inequality as we do when we solve an equation. That means, of course, we're going to work backwards to kind of unwrap our present. So I added 8 to 12, then I divided by 4, and I found that x is greater than 5. This means that the value of x isn't actually 5. It means that for any value of x that is greater than 5, it will satisfy or make the inequality true. And you know I always like to check my answer, so I'm going to pick a number that's bigger than 5. Let's go with 6, and I'm going to plug it in, substitute it, and check my work. When I substituted in 6, which is bigger than 5, my final line here said that we have 16 is greater than 12. Well, that's true. So I know that my number that I chose that was greater than 5 made the inequality true. And in fact, I could have chosen x to be 100. I could have had x be 55. I even could have had x be 5.1, 5 and 1/10, right? All of those would have resulted in an inequality that was greater than 12. And that's why when we are solving, I can also show this number line to show that any value that is larger than 5 would be a possible answer for x. Here's another one. 5x plus 20 is less than or equal to 5. So whatever our value is for x, we know that if we multiply it by 5 and add 20 to it, the result is going to be at most 5, right? It could be less than that, but it can't be more than 5. So the question is, what could x be to make this true? So we'll solve it just like we've done before, starting by subtracting 20. When I finish solving, I see that x could be less than -3, or it could actually be exactly -3 in this case, right? Less than or equal to -3. So I'll go ahead and test this, of course, by picking a number that is, let's go with less than -3, maybe -10. Well, when I get to the end of substituting in -10, I get an an inequality that says -30 is less than or equal to 5, and that sure is true, so I know that that is a choice that would work, and -10 is less than what I had as my bare minimum, which is -3. And as always, I represent this by graphing my solution, and since it's less than or equal to -3, it could be exactly -3. I'm going to go ahead and fill that in, but it could also be less. I'm going to go to the left, and that would be my solution. Anything -3 or below. People solve inequalities a lot, although they might not realize that that's what they're doing. So this is an example of a story where we would actually use inequalities to find the solution. So Mr. Atkinson wants to take a Lyft downtown. He has at most $20 to spend. The ride will cost $5 to start, but there's also a fee of $2.50 per mile. What is the maximum number of miles he can afford? Well, we know he wants to spend less than or exactly $20, so this is an inequality that would look like less than or equal to $20. And then we can kind of dissect the rest. We know that there is a $5 fee no matter what, so that gets added on no matter how far he goes. And then it is $2.50 per mile. So this is what our inequality would look like. And we can just solve this and figure out how many miles he can afford to go. When I go through the steps to solve this, I see that M has to be less than or equal to 6. So he can go exactly 6 miles or anything under 6 miles. And lucky for him, our school is just under 6 miles from downtown, so he should be able to get there with the amount of money that he has. And our graph below shows the solution to the inequality, showing us that anything 6 or less is fine, but of course if he had to go 9 miles, he would not have enough money. And for class, I want you to go ahead and try to solve this, find out what the possible value of G could be, and then of course include your number line solution at the end to show it visually. And remember, the essential question for this video was how do we solve inequalities, and hopefully we see that they're really very similar to what we've been doing with equations, just with that inequality symbol in between.